activity is called Be a Computer. I think what I said before summarises well. Computers do things all over the world. So often, you often think of computers in offices, but they're absolutely key now to the way we do surgery and medicine. They're really important for games. And the computer that I work with is this one, the BBC Microbit. And this, for example, is currently being the controller for my presentation. So I'm changing the slides using this. So computers can do all sorts of things. They're not just the things that we have in offices. This TV, for example, is a computer, and your phones are computers as well. And we kind of, fundamentally, we ask, how can computers do all of the things that they do? And the answer to that question is numbers. Computers only understand numbers. And if you look around here, you'll see these two whiteboards at the front. And you can see that all they've got written on them is numbers. So that's going to be a really important theme for today, is that computers understand numbers, and everything they do is about interpreting those. So even the instructions that tell a computer what to do are only numbers. So think about that. It's not even just that the information is stored as numbers. Even the instructions are just numbers. And the other important thing about computers is that they can only follow very simple instructions. Is that a surprise to anyone?
Yeah, to me.
Yeah, so computers, you can think about that. They do all these incredibly complicated things. If you think about who's playing Minecraft, quite a few. Think about how advanced Minecraft looks and all the things you can do. It's really complicated, but computers themselves can only follow really simple instructions. So here's an example of a computer following simple instructions and not really doing a very good job. So computers, we'll just watch it a few more times, because I tell you, it gets funnier every time. Computers, the trick of computers is they're not really very clever, but what they are very good at is doing these simple things incredibly fast. So let's see, how many sums do you think that you could do in 1 second? One sum, yeah, about one sum. I used to be able to do one sum in a second. Now I can do, maybe one sum every 10 seconds. I've slowed down. But maybe you can do 3 sums a second. And if you were really good, maybe you could do 5 sums a second. But that would be just too hard even to write down the answers. Okay, so you can probably do 1. How many sums every second do you think this can do? It's very small. Yeah? Maybe 20 or 10? Any other guesses? Yeah? Hundreds. How about 16 million? In every second, this thing can do 16 million sums. And actually, we're using sums to talk about simple instructions. So we said that those computers understand numbers. That means that all the things that it does are kind of like sums on numbers. So if you think about that, they're really simple. Just do simple stuff, but they do it really, 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 really fast. And that's one of the things that makes computers seem so magical to us, is that they're doing this stuff really quickly. So what we have to do when we're dealing with computers, and this was my job is as a computer programmer, and some of the people here at Nominet as well, is we have to break the complicated things we want to do up into much simpler instructions. So does anyone sort of recognise this from when you're doing coding? If you think about when you're coding, people recognise you have to tell the computer one by one what to do. You can't just say, if you're using Scratch, make the cat walk around in circles. You have to say, make the cat walk around in this particular way and add numbers to get it to walk around. So you have to break up into simple instructions. And so you're probably familiar with this. We've got people that have coded before. So normally you're saying, here's a simple instruction, do this, then that, then this, then that, then this, then that. And actually, on these boards here, these numbers, they are a list of simple instructions. And there are quite a lot of them. So they don't look like instructions now, do they? Who knows what 4802 means? Sinem knows. No one else knows. So these are supposed to be a mystery for now. You don't need to know what these are, but by the end of the session, you'll have an idea of what on earth 4802 means and how to do it. So, I've said this before, today instead of writing code that you might normally do, we are going to be a computer, and we have a number of different phrases that we use for what computers do. So we're going to be a computer, which ultimately means following instructions, but it's a lot more fun than just the normal kind of following instructions, don't worry. And we're going to execute code, so that's the other phrase we use. And here is a robot doing some execution of some biscuits. And the reason we have this is that actually executing code is a little bit like following a recipe. So how many of you have ever cooked a meal all by yourself? Anyone ever done that? Wow. Right. And have you ever seen, when you're doing this, have you ever seen a recipe book? Yeah. So actually, there's a real similarity between cooking, I'll just go back to this picture, cooking and computers, because you have a recipe, a set of things that you have to do and the right order to do them. And so as we talk about what's going to happen today, we're going to keep that, we call it an analogy, that recipe analogy in our heads, that comparison between cooking and computers. And we're not just going to be any computer, we're going to be a giant human-powered BBC microbit. So we've got a little one here, and behind you, Anthony has made a giant one. And that is what you're all going to be controlling. So if you look on the back of this one, take off the blue tack, we've got some little chips. And one of these chips is called the processor, and you are all going to be the processor on the microbit. Right. And in our simple computer, we have 7 possible instructions. So I want to check, because sometimes people say, I don't think I can be a computer, I don't know how to be a computer. So who's worrying about whether they can be a computer at the moment? You're all confident?
I'm pretty confident.
Yeah, I see a bunch of them looking at me going, of course I'm confident, Johnny. Why are you even asking me? So these are the 7 possible things that you could do. The first one is choose between 2 things. Who can do that? I hope all of you can choose between 2 things. Put a number into a box. Yeah, good. Read a number from the whiteboard. Yeah, it's a little bit like being at the optician at the moment. I'm not testing on how far you can read it from, but put a number from a box onto the whiteboard. That's very important. Yeah, good. Add 2 numbers together. Yeah. Multiply 2 numbers. A little bit harder. Everyone can do that too. And what about subtracting 2 numbers? Right, so all of you can do all of the instructions that you need in order to be a computer. And all of those instructions, ultimately, they're just numbers. So if you see, each one of these has a number 1, 2, 3, 4, 5, 6, 8. So if I ask you now, what do you think 4802 might mean?
Yeah.
Yeah?
So I'm just thinking of possible things that you could do.
Yeah?
And I'm thinking like typing something.
So these are, we only have 7 of these, so we don't actually have a clear thing which is typing in our list of instructions. So instruction number 4 is to put a number from a box onto the whiteboard, which is actually a much smaller task even than typing something. So 4802 actually is instruction number 4. So the instructions are just numbers, we covered that. But before we can actually understand how to do anything with this, we need to work out what the parts of our computer are. So each of our computer has lots of different parts, and they're all around you in the room, so it's easier than normal to look at what they are, because they're right here. So, who's heard about computer memory? Have you ever heard of computers? Yeah, and what's the memory of a computer normally? Someone who hasn't answered, yeah? Sorry, I can't see your name, but the one, I reviewed it, but
I'm not really sure.
you're not really sure. Anyone that is sure what the memory of a computer is? Yeah?
Information.
Yeah, it's the way the computer stores the information. So here we have the memory of the computer on the whiteboard. And actually this is really similar to computer memories. It's just a computer memory is really just a big table of numbers. So this is very similar to actual computer memory. So some of you, I've been talking for a while now, and I can see that you're beginning to get bored. If you could just listen to this bit, it's really important, because otherwise the rest of the activity won't make sense. So just stick with me for another couple of minutes. So the memory, here, the big whiteboards, that's where the computer stores everything. And the memory is a little bit like the shelves in the kitchen. So on the kitchen shelves, you have, what do you have on your kitchen shelves?
Glasses.
Yeah? Other things for making, yeah?
Like plates.
Plates? What about food? Do you have food on your kitchen shelves sometimes? Yeah, so you've got the ingredients that you need for the thing you're making, and you've also got the instructions, the recipes. You might have your recipe books on your kitchen shelves as well. So we have, in the memory, it's a bit like the kitchen shelves. Boxes on the workbench. So not all of you can see these. These are our boxes. And they're on what we call the workbench here, which is what we're going to work on. And boxes are a little bit like, boxes on the workbench are a little bit like your bowls when you're measuring something out. Before you use anything, you need to get all of your ingredients ready and put them into bowls before you can start cooking. So if it says you need 200 grams of flour, what would you normally do? Can someone tell me how to get 200 grams of flour ready? Yeah.
Pour it into a weighing scale.
Yeah, that's exactly right. And would you normally have a bowl there to pour it into? Yeah, on the scale. So our boxes here, they're like our bowls that we get everything ready in before we cook. So we can't just get stuff straight out of memory, we get it and put it into the boxes first. Okay, this is the most important thing I'm going to tell you today in order for you to be a good computer. So each one of these boxes, what's that yellow bit of paper? Can people see that? There's a picture on it. What's the picture? Yeah, just shout it out.
Key.
A key, right. So, if you remember one thing for this activity, you need to remember this. You can't read, which means you can't get a number out of a box unless you currently have the key for that box. Right, repeat that back to me. Okay, that wasn't clear enough, guys. I'm going to say it again and you're going to say it back to me. You can't get a number out of a box unless you have the key.
You can't get a number out of the box unless you have a key.
Brilliant. That was wonderful, yeah. It's never been that clear. So we need to remember that because otherwise, all of our numbers, all of our results, all of our sums will go wrong because we'll start overlapping with other expressions. So if you need the key, all you can do is wait for one of the other teams to return it to you. Okay, and then finally, the display. Well, not finally, we've got one more piece, but the display, that's here. We've got one microphone. We're going to use this screen as the other display because we've got two teams and therefore two displays. So our display is magic. Do you see we've got here, page 99 in the memory. So our memory is divided up into pages, 0, 1, 2, 3, 4, up to 99. So page 99 in the memory, if you ever store something into page 99, if I want to write a number, so let's say I'm a team and I'm going to write a number into page 99. Pardon? You've already got one? Okay. So I'm going to write 0 into page 99, is that allowed? Yeah. Yeah. So if I write 0 into page 99, 0 displays on the screen of the microbit. So page 99 is what we would call in computer terms, it's got a special name. You don't need to know the special name today, but it's called a frame buffer. But page 99 is where we write numbers, and if we write them on page 99, then they show up on the screen of the microbit. And then the last thing is the CPU, Central Processing Unit itself, and that is all of you. And that is like, in a big kitchen, you've got lots of chefs, and each one of them has a specialised task. So if you, in a really big kitchen, one person will be responsible maybe for chopping up the vegetables, and another person will be responsible for cooking the meat, and another person for preparing the plates and getting them ready. And we're going to be like a really efficient chef's kitchen. So together we're going to be working as a big team, all with our own jobs. Okay. So now we're going to split you up into teams. So I need you all to stand up for a moment. And if we've got, should we have older and younger siblings together?
Yeah, that would be nice, wouldn't it? If you have a brother or sister, you might want to work together because we've got roughly 5 things to do for a team.
Yeah.
So you're probably going to end up working in pairs, so you might want to get together with your sibling.
Yeah, so we're going to work in, we've got 5 things to do, and I think we'll add an extra role, which is the pipeline manager. So first, is there anyone feeling super confident? They think, you know what, can I do this? Yeah, great, we've got 2 of you, that's great. That's 2 pipeline managers. So you 2 are going to be our pipeline managers. So you want to come forward, that helps. That means we've now got 10 per team, so much more manageable. So pipeline managers, you're going to come forward and stand here. And we don't even have badges for you right now because we just created a new position. Yeah. So can you please find a pair that you want to work with? And when you found your pair, then I want you to sit back down. Who likes sort of, who thinks they like tricky tasks? Quite important, tricky, a little bit tricky, you've got to watch out for some little details. Your hands went up quickly, so you're going to be our getters. So you're going to be the get team. 1,
And who are our getters?
2. And what about this side? People that like tricky details?
Okay.
I think you 2 both, well, are you a pair? Great, okay. So,
I'm coming.
oh, you've got a
Which one?
Okay, there's a get team. Oh, I have, right, decode team, can you give me your, oh, Anthony, you've been following up with instructions, brilliant. Okay, right, what about, so we don't have to, so who hasn't already got a role, but is quite good at maths? Yeah, okay. So you can be our do team
Yes.
on this side.
Addition, multiplication, subtraction. All right.
All right, good. We've got our do team there, and we've got.
Perfect.
So who's left? Who hasn't got a job? You're our put team this side. Actually, that's a really important one because you are responsible for making sure that everything gets put back in the right place.
There you go.
And actually, that means you're preparing for the next instruction.
And the last one is the 15.
Okay. So we're going to go through an example. So we've got beginnings of the memory here, but actually we're going to use the real ones. Can the count team, just make sure we've got space down the middle for people to get. We're going to have some people coming up the middle in order to get to the memory. So, instructions within the pages of memory. You know this. Every instruction on the whiteboard is 4 digits. Can we see that? And the first digit, we've already talked about this, is the instruction type. So, and the other 3 digits, what they do depends on which instruction type you've got. So that's why we've got question marks here. Okay. And there are 7 instructions. Can anyone remember what instruction 4 is? If I cover it up, can you remember what instruction 4 was? Yeah? Yeah? Really good. That's fantastic. So, but each instruction has a different role. And the boxes before we start, they actually don't have zeros in them, but they should. So pipeline managers, where are you? You need whiteboard pens. You need these whiteboard pens, and you need to give the whiteboard pens out in the right colour to each group. So you've got a colour that matches the colour on each label into each group, and then you need to zero all of your boxes, which means put 0 into the bottom of every box when you're done. Right, okay. So, are we ready, everyone, to start a worked example? Yeah? I want everyone to just think for a moment, get ready, it's going to be calm, and then put your hand up when you've decided you're ready to start. So we're all together on this, and everyone's listening. Hands up, hands up. Good, and pipeline managers, have you managed to zero all of your boxes? All right, we've got one pipeline manager. I'll let you keep doing that while we work through. So, this is the whole activity works around these clipboards. Right? So this is what we use to manage the instructions as they go through what we're calling the pipeline. So you're a bit like a pipeline, because we're going to run all the way along, like water through a pipe. The instructions are going to run along the table, and they start like this. So we're going to just follow through, each team following their instructions. So, count team, it says, wait until both the IP key is back on the workbench. Is the IP key back on the workbench? Instruction pointer key there? To the box? It is. Right, so it's in the box, you've got it, and you've got the clipboard. Are those things true?
Yeah.
Great. So, next instruction on your list is? Stand up. Great, stand up. Copy the value in the IP box.
Which is the instruction pointer box.
Yeah.
I got it right there.
So let's, shall we intersect and put this to 50? We should. Yeah. So we're going to start. Do you see how on the whiteboard we've got 3 chunks of numbers? Can everyone see that? You've got. It's maybe easy to see. Oh, it's easy to see on this one. You've got a chunk of numbers there, a chunk of numbers here, and a chunk of numbers here. We're actually going to start at 50, which means we're going to do this chunk of numbers. And these are 3 different programs. So just like on your phone or on your tablet, you've got a lot of different apps. Who's used a few different apps on their tablet? Yeah? These are like 3 different apps. And we're going to start with the 3rd app, which means that we're going to start with 50 in the instruction box. So, copy the value in the instruction pointer box.
So you have to write it there.
Right, what's the next instruction?
Okay. So what does it say?
So add 1 to the value of the box, but don't change the number on the clipboard. So first you've got to copy it onto the clipboard. Yeah, exactly. So 50 on the clipboard, brilliant, and then add 1 to the number in the box, but not on the clipboard. Sorry, this is the box here.
But you don't change
I'm
it.
going to make that 51.
Okay. And the clipboard to change.
So once we're going to do this once, it'll take a little while, but after that we're going to go really fast. Especially given how fast I saw you getting into position, I've got high hopes. So then it says, take the IP box's key and put it on the clipboard. So yeah, you take the whole post-it note. You see that yellow thing? You can take that all at once and stick it there on the clipboard. So actually, let's go through this. Sorry, we've got so for everyone else to see what's happening here, we took 50, we put it up here, and then we put the IP key sticker or thing on the clipboard. And then your next instruction is to pass the clipboard to the decode team. So decode team. And then what's your last instruction?
Decode team ready?
Count.
Yeah.
Sit down. Okay, and decode team, your first instruction is sit down and wait for the count team to give you a clipboard. And then what's the second instruction? Stand up. Good, you're on. That means you're up. Okay, so we pass the clipboard. Read the instruction pointer value from the clipboard's left corner. So on the clipboard's left corner here, you've got an instruction pointer value. What value is that? Call it out. 50. And then the next thing is, oh, you've already got the IP key, sorry. Copy the 4 digits from that memory page to the 4 large boxes on the top of the clipboard.
So if you two run over here,
Sorry, you are here. So you go to the
see,
page.
this is the memory.
That's there. Put this in
What
front
number have you
there.
got there? So can you find number
Copy
50
that
on
value
here?
there.
That's right. And can you see what that number is? Can you put those 4 digits into those 4 boxes?
Yeah.
We're going to be the other two.
Right, so let's see. So one of the important things about engineering, which is the job that I do, is you're always looking for ways to improve the things that already exist and make, for example, a CPU or a processor better. So I want you thinking as you go along, what's making it hard for you to do this? Are you too far away from something you need? Do you have to keep running up and down? Are our computers badly arranged? Because actually, a big part of this activity is firstly being the computer, but secondly, we're going to be thinking about how we can rearrange our computers to be more efficient. So after you've done the first program, we're going to rearrange the computers, and then you're going to race not just with the computer that we designed for you, but with your rearranged version of it. And then you'll be racing not just with how quickly you can do the instructions, but how well you've rearranged your computer. So 2 things to be thinking, bearing in mind, as we do the next 5 instructions. Am I doing this kind of accurately and quickly? Are we familiar with the process? And what's getting in my way? How can I improve this? So, I'm going to give you a warning. The next instruction we're going to do is different to the ones we've done before. We've done 2 instruction type 2. There are some kind of cheeky little differences in this one. So I'm not going to work through it because I think you're good enough that I don't need to work through it on the board. But I want just to work through 4802 carefully. But I am going to start timing you. So we start to get an idea of how long we're taking for each instruction. Because when you're good, you should be able to do the whole instruction in less than 60 seconds. Less than a minute per instruction. So I'm going to start timing you so we have our baseline. Good job. You've got the first 5 numbers correct. I can confirm that they're correct. We had a little chat amongst computer 1 about what we thought this number looked like. So what about for computer 2? What did you recognise that? Yeah.
Yeah.
Yeah. Harry?
It's like on some telephone numbers, it's the first 5 digits.
It is. It's the first 5 digits of an Oxford telephone number. So you are currently in Oxford. There's a phone in the corner of this room. So can anyone guess what our program might be trying to do? Someone from this one? Because we've already had a talk. Yeah.
Maybe try to teach us phrases.
They might be trying to teach you phone numbers, but which phone number specifically?
I don't know.
Yeah, so the phone there. So if you get all of the instructions correctly, or you follow all the instructions correctly, you'll print out the number of this phone. And the reason we're racing is whichever team can get the number first. I will ring whatever number your computer generates. So that's my point. So I need you to be really careful to make sure you're doing everything right, because I'm going to ring it and I'm going to have to explain to someone on the other end of the phone why I've rung the wrong number if you don't get the right number. So that's the challenge to you. And you know what? That's a lot of trust, because you could deliberately get it wrong, but I'm sure you're not going to. What we're going to do now is we're going to have lots of clipboards running through the computer all at the same time. So this is going to be the right kind of chaos. That's what I told Anthony and Chidem when I told them we were going to do it today. I said it was going to be the right kind of chaos, because there's lots of stuff happening all at once and you're going to really focus to get it right.
Can you edit the tables to make a better design?
Yeah, if you want to edit the tables quickly to make a better design, please do.
So can you explain to us a bit, what did you do today here?
We basically acted out what a computer did and had to decode some of what would have been coded into a computer.
Okay, what kind of a program was that? What did you get at the end for the program?
We ended up getting a phone number that
Oh.
phoned one of the phones in the building.
Okay, and how did you organize yourself to be able to do this program?
We had different people basically go. So we had different sections, so they wrote down the numbers that we needed. Then there were people that changed them
Yes.
and then wrote them into boxes and then also wrote some onto a board,
Okay.
which is then how we got the phone number.
Oh, excellent. So what was the most exciting part of the activity?
I quite liked it when we got to do lots of boards at once
Mm.
because it was going faster and you had more stuff going on.
Okay, do you remember what it was called when you had multiple clipboards?
It was called a pipeline.
Pipeline. Okay, so that was the exciting part.
Yeah.
So we acted out being a computer, kind of executing the code that someone programmed in.
Mm-hmm.
And so there was different parts of, so each step of the process was a different group of people. And so we got numbers on the board and then it went round and everybody did a different thing to them, and in the end we came up with a phone number.
What part of the team are you working on?
I did do, so that was getting the numbers that they got and then either like adding, multiplying them or writing them on in the memory.
Okay, so what was the most exciting part of the activity?
I quite liked it when we were racing against the other team to try and do it quicker
Uh-huh.
and better than them.
Did you manage?
Yeah.
Excellent, good job.